Okay, so what I want to talk about in this lesson is the idea of the law of conservation of mass. So we have this idea. Let's change the color. So the law of conservation of mass. So there's this French scientist, and this is the guy here, and his name was Antoine. So I'm just going to put his name down here. Okay, and this was, it would have been roughly back in the 1700s, so around 1774. And what he was interested in is he was interested in carrying out very precise experiments and looking at what happens when chemical reactions take place. So one of his experiments that he done was this one here. So what we have here, so on one side we have mercury. So just pure mercury. And mercury at room temperature is a liquid, and you can see here it's a silvery type of liquid. And what he done was he set up an apparatus. So he had like this, he took the mercury and he put it inside a sealed bell jar like so, and then he measured the mass of the mercury and then all of the apparatus that was around the mercury as well, you know, including the jar and let's say this bottom piece as well. And this was completely sealed in air as well. So all you had was the two reactants coming into contact with each other. You had mercury and then you had air, and it was completely sealed inside one of these sealed bell jar, which were made of glass. And then what he done was he used heat from the sun. So he took a magnifying glass and he magnified the light through the glass and onto the sample of mercury. So he essentially heated it up using the energy from the sun. And this acted as a catalyst to a chemical reaction. And let's say if he weighed the whole lot out, and it weighed, let's say if it started off as 2,527.34 grams. So that was the weight that he started off with. And that's the weight of everything. It's all of the apparatus and a sample of mercury. And then what he done is he heated it up with using sunlight. And what he found was that after a period of time, a chemical reaction had taken place, or a change had taken place. So the silver mercury had changed into a red powder. And this is what's known as mercury oxide. So essentially a chemical reaction had taken place. Now, what was really important and what he noticed was that the weights stayed the same. So he started off with 2,527.34 grams, and he ended up with 25. He ended up with exactly the same weight. So what he started off with was equal to what he finished up with. So there was no change in the mass. So what has happened is the mass was conserved, and this was really the basis, let's say. And he done many other experiments as well. But what he noticed was that the mass of the reactants was equal to the mass of the products. So you have reactants mass after the reaction takes place is going to be equal to the products mass. And this is what we mean by conservation. So conservation really means stay the same, or stays the same. So essentially what we're saying is that the mass has been conserved the whole way through this change or chemical reaction that's taken place. So what this really careful experiment that he carried out demonstrated is that mass is conserved. So the mass of the reactants is conserved all the way right through to the mass of the products that are formed. So if we have a look at this in just a little bit more detail, so what we have a reaction happening. So we have essentially, we have mercury plus oxygen. You have a reaction happening, and that's turning into mercury oxide. Or oxide. So, and the catalyst, or what gets the reaction going or the change taking place, is the heat. So heat from the sun. So this is so a word equation, for example, for the reaction that's taking place. We can also look at it like this. We can use our chemical equation. So we can have 2 moles of mercury, and the chemical symbol for mercury is Hg, plus 1 mole of oxygen, O2, will react, and you need heat. Heat is like the catalyst that gets the reaction going, will give you 2 moles of mercury oxide, or mercuric oxide, HgO. So what he's saying is, so imagine if you started off with, let's say you had 4.02 grams of this, okay, of mercury, and you had 0.32 grams of oxygen, and these react together. So the mass is going to be conserved. So what you will end up with then is you'll have 4.34 grams of this mercuric oxide. And this is, so what essentially is happening is you are getting a combination. The mass is being conserved from reactants to products. So this is what was happening inside in the jar here. So you had air, okay, and the mercury, the silver mercury here, was coming into contact with the oxygen that's in the air, and a chemical reaction was happening. And as a result of that, the oxygen was combining with the mercury, and it was producing this product, which is mercuric oxide, which is a red powder. So if we think about the air, for example, so what's the air made of? Like, what's in air? So air is made up of a few things. It's a collection of gases. So air, so the things that are in air, so you have oxygen, okay, or O2. You have nitrogen. And the majority of the air is actually made up of nitrogen. So you have nitrogen. You have H2O, or water vapor. So you have water in the form of steam, for example, or in its gas form. So water. And you have CO2, or carbon dioxide. So carbon dioxide, it has 2 oxygens within it. So generally, and then you have all other kinds of like dust and microorganisms and all other kinds of things in the air as well. But generally, if you're to take the constituents of the air and what it's made up of, it's made up of this is what it's made up of. It's mainly made up of nitrogen, and we need oxygen. We need this oxygen in order to survive. So, like, what's happening is inside in this sealed glass jar, you have loads of different like oxygen molecules, nitrogen molecules, water vapor, carbon dioxide, and they're all kind of moving around, and they're coming into contact with the mercury. But what's happening is the chemical reaction is happening between the mercury and the oxygen, and you're getting this mercuric oxide being produced. So from this careful experiment, the law of conservation of mass was developed based on this. So what does the law of the conservation of mass actually state? So what it says is that, so it states that, So when a chemical reaction, okay, so this is our chemical reaction here that's happened in this case. When a chemical reaction occurs, the total mass of the reactants is always equal to the total mass of the products. Okay, so this is the law of the conservation of mass, and this is like if you just take it and put it into words, this is what it means. So when a chemical reaction occurs, so chemical reaction. So this is our chemical reaction here. So mercury reacting with oxygen. So it's happening here inside the apparatus. The total mass of the reactants. So the total mass of the reactants. So here on the left hand side, so these are the reactants. And then you have the mass of the reactants. So if you have 4.02 grams of hydrogen or mercury, and you have 0.32 grams of oxygen. When you combine the two of these together, you have 4.34 grams of reactant. So is always equal to the total mass of the product. So when this reaction happens, these two masses are always going to remain the same. Okay, so what happens is the mass is conserved from the start of the reaction to the end of the reaction. And that's essentially all it is. That's what we mean by the law of conservation of mass. And this is very, very, very important because it shows that, first of all, it starts to give more credence to this idea of the particle nature of matter, of everything around us. And it was used then as a way to further progress other ideas within science as well. But essentially, that's what we mean when we talk about the conservation of mass, and that's what we're talking about. And if we notice this as well, like if we have a look here, so if we look at the mass of mercury starting off, that mass increases. So it does here. So you can see it started off with 4.02 grams, and that's gone up to 4.34 grams. So that extra mass that the mercury has acquired is coming from the oxygen that's in the air. So this mercury in here, when it's heated up with the sun, it starts to react with the oxygen that's inside in the air, and its mass increases as it changes into mercury oxide. So that's one of the observations that they made. So the extra mass comes from the oxygen gas that has combined with the metal. So that's where it's coming from. Now, also as well, when you open the bell jar, when he carried out this reaction, and then we had the powder produced. When he opened this bell jar as well, what he noticed is he heard like air rushing in. So he did into the jar. So what he figured out from that was that oxygen is also being like consumed inside the air, and as a result of that, what was happening was there was a vacuum being produced inside in the bell jar because the oxygen was being used up, and it was essentially creating a vacuum. And the minute, so inside here there would have been space because the oxygen that was occupying the space inside here was being absorbed into the mercury. It was leaving space inside here for other oxygen or other atoms that would have been outside in the environment to rush in and take that space that was occupied by the oxygen. So again, it was creating a vacuum as well, and this again just adds further credence to this idea or this law that he developed as well. And this is the basis of science. So science is all about like careful observations, setting up an experiment like was set up here, making careful measurements, and then just noticing what has changed from the start to the end, and then making like logical and clear prediction or clear explanations of this like phenomena that he was observing here as well. And that's what we got from the work that was done here. And it's the law of the conservation of mass. And that's basically what it is in a nutshell. So hopefully that makes sense. Okay, and thank you for listening.